Okay. Good afternoon, everyone. We would like to welcome you all to our very first Nuearth Soil Information Zoom meeting. I'm Shane Carter. I am a Nuearth sales representative. I'll do my best to be your host, so wish me luck. I would like to introduce to you the stars of our show today. Ken Sabatier. He is with Overton Environmental, and we'll be discussing about their Equity product and explaining what biologicals can do and how to integrate them into your crop. They have 5 years of research to back it up. I'd also like to introduce Neil Wager and Bryden Newells. Both work with the research behind the great Eco-Tea. We also have Dave Stroschein. He's with Nuearth. He's our operations manager. I think that's his title. Thor Stroschein, he's also with Nuearth. He's our customer service specialist. And we would like to thank Randy Wogelmuth of Sunrise Group for setting up this Zoom call and trying to get us through here on our first one without us screwing it up. Ken, if you'd like to take it away.
Okay, Phil, Landon, and Matthew, hopefully everything's coming all clear for you. I'm Ken Sabatier. I've been working as the Director of Operations and General Manager for Eco-Tea since 2018. And at that time, we were just an infant company in agriculture who had a biological product of biology and biostimulants with the goal of getting it into mainstream conventional agriculture. And that all started with theory and ecology theory, hence the word Eco-Tea. But theory needs to work in practice. And so over the last 6 years, we've been doing all sorts of different trials, both plot trials and field scale trials. And then the goal of this presentation is actually to educate all of you on what we found and on how to work with biology in a conventional system, and just lessons learned, what we've learned, and how that works. So that's just a bit of my background. On the screen here as well, I have Braden Niles on there, so I'm more of the generalist, and I understand the science and how we've made it, and a lot of that. Braden, though, is our research agronomist. He's a farmer himself, and a lot of the data that we're presenting, Braden's the guy that's gone and got it, assimilated it, and made sure that our conclusions are correct, and and how it works on a farm. Braden, he's both an agronomist and a farmer, and on some of your questions that you may have, he'll be better to answer them. So that's why we have him on. So this is recorded. I think that we're through the intro. So what I'm going to do is I'm going to get to sharing and dive right into this. So, like I said, our research here, well, I'm getting, okay, the feedback stopped. No, the research, when we're talking about soil and soil health microbes, it's roots, microbes on roots, and microbes in soil that actually do things. But every farm, microbes in isolation, they can do things, but no farmer farms in isolation. Every farm should have a chemical plan, your fertilizers and herbicides and different things like that. It should have a physical plan, and that's your crop rotations, your tillage practices, how long you keep a living root in the soil, those things. And then there's a biological plan, which for a lot of farmers, that is a new thing. But, and in the research that I'm going to talk to specifically today, a lot of it has to do with the idea of soil health. And chemistry does not change soil health. You can put all the chemicals you want in your soil, and you're not going to improve your soil qualities, your aggregation, your water infiltration, compaction, that type of thing. That happens through biology. And the aim of my presentation today is go on and explain what happens, how that happens, and whether you make money on that or not. Just to give you a bit of context and understanding of the conclusions that I'm going to show you. So a lot of our conclusions, I'll show you snapshots of what it does, but I want to give you the confidence that there's hundreds of plot trials behind this. And so we started out with plot trials across the prairies, a number of different sites. But as well as we got capacity and scale, we have both field trials through farmers, but as well in Langham, Saskatchewan, we've been renting a 15-acre site just outside of the Ag and Motion area. And we've been doing multi-year research there. Basically, with 6 different farm practices, from full conventional no biology to aggressive biology and different types of fertilizer and chemical reductions. And year over year, we've been looking to measure if you adopt regen things or soil health things, are you making money or are you losing money? Because ultimately, no one should be adopting a practice and going, well, I might have to lose money for 2 years, hoping that you're going to make money. And the data that I'm going to show you should give you some assurance that that's not the case. In here, this is just an illustration. So over the last 6 years, these are all the different third-party sites that we use to try both our seed dressings and our soil applications. So in our soil applications, we have an in-furrow, and we have a residue digester. I won't be talking at all about our foliar stuff because that's much more advanced biological. And honestly, if you're just starting with biology, don't start with a foliar because it's complicated. But once again, I'm just showing you the breadth of the regions and the data that we're gathering it from. What we've wanted to do is make sure that we're hitting every soil zone on the prairies, and as well the different climate zones. So in the trials, and when I talk about eco-T or even just biologicals in general, you have biological inoculants, so live biology that can get applied to the seed, or you have biology that can get applied to the soil. And there's a distinction in that. In that when you apply a seed dressing or eco-T seed dressing, it affects the root zone. Like biology doesn't swim through the soil. Like there is some mobility, but in general, the plant biology, if it's not associated with a living root, it just goes dormant and waits for a living root to appear. And that could be a weed, it could be a cover crop, or it could be a plant that you grow. So the reason that seed dressings work and are important is from the time that seed germinates, it's immediately forming a relationship with the right biology. And on the left side of this slide, and this is just an illustration, these are soybeans out at our trial site in Ontario. I have wheat pictures and oat pictures and corn pictures that show the same thing. And you would see this on your farm if you do this, where you have plants that have no eco-T and plants that have eco-T. On the left here is an untreated. And what you'll see, there's big primary roots, the tap roots and things like that. Those are plant driven. And when a plant doesn't have a lot of biology associated with it, the plant is expending nutrients and energy, pushing its own roots out to get its nutrients and grow. On the right side, you see a whole primary roots, but then a whole bunch of fuzz. And that fuzz is secondary, tertiary, and there's even quaternary, like, if you looked under a microscope, there's even more roots on this thing. Those roots are actually, microbes are what drive the growth of that. When the microbes get associated with a plant, they want more roots because they're trying to grow and colonize that area. And they feed the plant that enables it to grow these micro roots, and there's a symbiotic relationship. And this is important when I get to the next slide and we start talking about how nutrient deficiency works and why you can consider reducing fertilizer. So our other product, so a seed dressing, it affects the root zone. Those microbes on the soil, because some of the questions we get, well, if I use Eco-T once, do I have to use it the next year? Those microbes that are associated with that plant, they don't swim and move to in the middle of your crop row where there's no living roots. They're sitting there on that plant root, and that's where they stay. And in winter, when it all freezes, some of them go dormant, some of them die off because anyway, the nature of some of the different species. So the soil application, so I always say your seed dressing, it affects the root zone. Now, this is one of the reasons why intercropping and cover crops are important, because the more roots you have, that actually brings microbial mobility in your soil. So the in-furrow and the residue, though, so those are in-furrow, if you have a liquid kit, it gets sprayed on and put on in your seed row. It's different than the seed dressing in that there's way more liquid and way more biology. So rather than just affecting the root zone, you're actually, when it's going in furrow, it affects a wider zone in your soil. And some of the natures of our biostimulant ensure that it's more persistent than just what's on the seed dressing. And the residue, just as we call it, it's something either in the spring or in the fall that you spray on your field, and you work it in with either a light harrow, because it's important to get soil contact and moisture retention for it to do its work. That product actually, it helps accelerate soil changes in a different way than the seed dressing does. These two things in combination have a powerful effect. So one thing I didn't mention is each slide here now, I'll give the opportunity for any questions before I go to the next slide, just so we don't forget it. If there aren't any, we can still ask them at the end. But before I go to the next slide, does anybody have any questions or at this point? I'm hearing none. So the meat and potatoes. Do you make money or lose money when you use biology? So there's a single year effect that you can expect from microbes. And one of the things that, why I'm not specifically talking about just Eco-T all the time is, if you want to get value out of biology, you've got to work with it. If you just take biology and put it on a full conventional program that does, things that kill biology or reduce it or slow it down or inhibit it are high salt fertilizers. Salt's the best preservative in the world. More salts kill biology. Fungicide on your seed, well, guess what? Put Eco-T on a fungicide treated seed and all the fungi will die. Now, the corn, for instance, and this is the trial representation I have here, all the corn that we try, it has fungicide on it, kills all the fungi, but all our bacteria survive, and corn likes bacteria. So that's why you'll still see an effect. Tillage. So the more you work with biology, it works for you. So in year one, and this is where our largest body of trial work has been done with our seed dressings. And in 1 year, what's the risk of reducing your fertilizer, both nitrogen and phosphorus? So in all of we've done wheat, oats, barley, corn trials in all of those crops in nearly all of those sites that I had on the map, although corn we've only done in Manitoba because Grand Prairie is not growing a lot of corn. But we do what we call as bracketing. So when we trial these sites, we've done, we started with a 10% and a 40% reduction. We were trying to bracket and see how much it did. But what we've ended up doing is on all our trials now that we've continued to do, we do a 20% reduction and a 40% reduction. And over time, we've learned Eco-T seed treatments, regardless of whatever you're doing, if you cut your nitrogen back by 10% and your phos by 5 or 10%, okay, I think I'm back on here. No, so microbes, so when you have Eco-T, it's actually full function biology. So we have nitrogen fixers, phos solubilizers, iron scavengers. For every mineral, there's actually a microbe behind it that helps a plant out. But the main mechanism of what allows a farmer to reduce 10 to 20% of their spring applied fertilizer is a lot of those fertilizers are not mobile. Like for instance, phosphorus, when you put it down, it only moves like 0.2 millimeters in the soil annually. It's a very immobile, and it's root interception that gets that nutrient. So when you look at the picture of those big tap roots or the big fuzzy roots, those fuzzy roots are what enables a plant to access more of those nutrients. And even when you get a agronomist recommendation from a fertilizer company, and that recommendation already takes into account leaching and denitrification and a number of different things. There's a 10% fudge factor built in there. When you have microbes, that's the delta that it's clearing up. So reduce leaching and denitrification, there's actually chemical and microbial things that are going on that happen that enable that. And the other element in there is in Eco-T, all those different functions that we have on our, we're not a single species or a single function. Like it's not just a nitrogen fixture, it's in everything. And I won't get into how that happens, that's a whole different other presentation, and the Nuearth folks can explain it. But all of those functions are present on your root system, and that is what it enables. We see better iron transpiration, we'll see better calcium uptake, all these different things because it's microbes that are doing that. So this trial representation here, this is simply just a snapshot. We have data from 2018 to 2024. 80% of the time, so this example actually shows a yield increase in corn and oats are the two crops where we most often see a fertilizer reduction and a yield increase. I would have to say though, on cereals and peas, you're shooting for maintaining your yield target. Occasionally you may out yield, but I'd go, it's maintaining your yield. Using biology typically isn't going to give you a yield increase with less fertilizer. That's just, it happens sometimes 20, 30% of the time. On corn, there's actually a reason why that happens. I won't get into it. No one on this call is a big corn grower. But in this trial that we had here, this was a large plot trial at the Patterson grain site. They call it the Sir William Stephenson site just outside of Winnipeg. The treatment one was commercial full fertility. We were going for 170 bushel an acre yield target. We didn't get that high, but all things being equal. So the dry seed treatment on top of the corn with an 80% fertility reduction, and there was 160 bushel yield. And the liquid seed dressing pretty much achieved the same thing. I throw that up there just as an illustration to say we have a body of work, but we've actually have more data on wheat, oats, and barley than we do corn. Any questions at this point? I know I've been talking fast and presenting a lot of things, but any thoughts or questions right here? Okay, hearing none. So that was single year results. What we've done at our Langham, Saskatchewan site, so this is a 15-acre site. Each of our trial strips are 1.5 to 2 acres, like 1.75 acres. And there's 6 different strips, plots. 2 of them are conventional. Our grower standard, basically, we go with just your conventional agronomist recommendation. And this is all done by a third-party agronomy company called Grow West Agro. So Braden leads our research and what they do, but we always try and have someone else's hands doing this, because if a farmer can't follow our instructions and achieve results, anyway, we want a third party doing it, so we know that it's clean and representative of what a farmer would see. So the grower standard on the left, it's full fertility. There's a herbicide program that was granular fertilizer and zero biology applied over 3 years. The aggressive regen, which this is, we don't tell farmers to reduce your full fertility by 50%, but in year one for 22, 23, and 24, plot 2 has had 50% less fertilizer than plot 1. Plot 3 was only a 25% reduction, and the difference between 2 and 3 was 2, we were using liquid fertilizer. Okay, and their Omex products have less salts in them, which help benefit biology. So that's one of the reasons we wanted to test the difference between, a MAP, a higher salt fertility versus a fertility that has lower salt and helps biology more. And then on plot 6, we call that our check. It was basically plot 1, but with the 25% reduced fertility. So over 3 years, and Langham's not far from eastern Alberta, 22 and 23 were pretty dry, actually exceptionally dry. I think each year it was a total of about two inches of rain on the sites there. So the wheat and canola yields were okay at best. But 2024, we actually it was a good representative year. But when you take the cumulative, so this graph here, and the Nuearth gents have this in more detail, but over 3 years, the grower standard got 270 pounds of nitrogen, 150 pounds of phos, and its net yield of everything combined was 100 bushels. And when you look at the 2 plots that had biology, so both plot 2, it had Eco-T seed dressing and in furrow every year applied with the liquid fertilizer. Plot 3 was Eco-T seed dressing and residue digester. And one of the things we found is in furrow and residue digester seem to be achieving the same types of similar things in terms of nutrient cycling with residues and stuff like that. But the key takeaway here, and Braden, if you do have a question, the net costs in here factor in everything. Different prices of fertilizer, your different crop prices that year. In the case of residue digester, it requires an extra pass on the field, so we have added fuel. Like it's a true, what does this cost the farmer?
Yeah, it's a cost and return analysis. So it's your direct variable costs and then some added variable costs, such as extra passes with a sprayer type thing. Yeah.
So over 3 years, what we wanted to show is if you integrate biology into your program and reduce fertilizer, what's the risk? And this is purely just from the yield perspective. The next slides I'm going to go to are actually going to get into the soil health perspectives. And those are where things get really exciting for a biology guy like myself and Braden. But so on this slide here, are there any questions from the group or comments?
I'm not sure if anyone's nervous or not, but if you're nervous and scared to ask a question, you can text or email me or David or Thor if you have questions.
Or they're probably just trying to absorb my verbal torrent.
Well, that could be it, but I don't think so.
Okay. I feel like once I get on a roll, I really get going here. So anyway, here comes the real exciting stuff. So hold on to your chairs there. So the project that we undertook at Langham was actually to soil health. What is it? They're actually USDA, Department of Agriculture, has some very good defined things, but soil health, you know, soil health pivots on carbon and whether your aggregation and different things like that. But how do you measure it is one question. And we've learned and done our research and that. And we actually have, I'm going to show you 3 of some of the key metrics. So water infiltration, compaction, and cation exchange capacity. We have about 5 other variables that we could show you in terms of nutrients and things like that, but it would make this presentation another hour long. So all of these plots, so these are all plots 1 to 6. The yellow ones are the grower standard. The green ones are sort of our primary regenerative ones. And the black ones those are more experimental things going on. Plot 4 has a really large saline strip. So we've been doing we've been like triple dosing Eco-T to see when it's high salt area, does biology actually improve something? And plot 5 it actually started out as conventional and it's an incremental plan. So in year 1, you do no biology. Year 2, you use a seed dressing. In year 3, you use a seed dressing and a residue. And it's trying to see if you adopt an incremental approach, do things happen slower? But what I'm showing here, so what we've tested, so in year 1, every plot had pretty much the exact same water infiltration score. And this, if you're not familiar, Nuearth folks know how to, if you go on YouTube, you can actually see how to do a water infiltration test. And this is something you're able to do yourself to measure whether you're improving, if your plan is improving your soil. And it's basically, a 4 or 6 inch steel ring you pound into the ground, you pour, a prescribed amount of water in, and it represents an inch of rainfall. And then you just time how fast that water disappears. So in this test, this is what we're showing here. And we're showing in year 1, all of them were the same. 3 years later, these are the results. And these are not on just one pick your little spot. Every one of these plots have multiple GPS year-over-year plots, and we take the aggregate scores of that. So the water infiltration inches per hour. So this represents if an inch of rain fell, or in one, Braden, maybe actually you pipe in and explain the inches per hour thing, please. You're on mute there.
Yeah, no, well, it's a timed event, so you simulate a rain event by you like to start with a soil that is primed, so it's wetted down, and you add enough water to simulate an inch of rain after the soil's been primed, and that way you time it, and however many minutes and seconds that is, you divide that into an hour to 60 minutes to figure out how many inches per hour that soil is capable of.
So on the grower standard, in 1 hour, it would be able to take 4.5 inches of rain.
That's
on
correct. Yeah.
The 2 regen plots, they could take 16 and 18 inches of rain.
Yeah, they're getting up to 15 plus inches of rain.
Yeah. And it's a measure too of water holding capacity. So if you get a whole bunch of water, can your soil actually hold on to it as opposed to go into the, the Vermilion River or the Battle River.
Yeah, that's the key factor. Is that water able to penetrate into that soil? Is that soil able to have a physical ability to hold that water? Aggregate stability. But I think Ken's going to be coming to that in a minute here.
Yeah, and so those were, the previous slide was the real numbers, and so this was actually this graph here shows the percent change from, so the baseline in 2022, after 3 years, everything above the line improved, and actually the grower standards ones where no biology was, they both got a little worse. I don't know all the reasons, but anywhere where there was biology used and used more aggressively, so plot 2 is the aggressive biology, we saw the most significant improvement from the baseline. So when people say, man, if I could only buy water, when you improve your soil health, that is actually something that it enables you to do. It is when you get rain, your soil can hold on to it better. Are there any questions here before I go on to compaction, which is a direct correlation with water infiltration? I want to ask, has anyone on the call here done a water infiltration test on your field or pastures? No?
Again, don't be shy, guys.
No, well, an interesting thing to know, to go.
Yeah, we like to, we don't do as many water infiltration tests anymore, but because they're a little more time consuming, but we do a lot of compaction testing.
Yeah, penetrometer.
Yeah.
But if you've got time in July that you're out there walking your fields or scouting, you do a water infiltration test, 4 feet off your field, close to the ditch, and do a water infiltration test in your field, and just see what the differences are. And it's a good illustration of how farming affects that land, over time. So a direct relation to this, so on all these plots as well, we do penetrometer tests, and this is probably something you're more familiar with. Once again, in year 1, pretty much all the plots were at an equal baseline. They registered all the same within about a 5% differential. And we test to 250 PSI. The reason it's that is most plants at 250, they have a hard time penetrating soil that is compacted at higher than 250 PSI. Braden, correct me if I've got that a little bit wrong, but I think that's right. I see a nod, so I'll carry on. So what this shows is over 3 years, this was the percentage change in compaction on all of our plots. So the grower standard, there was virtually zero change, no biology, no change in water infiltration or compaction. Plot 6, there was a slight improvement, and some of that could just be test variability. But on all the regen plots, there's a consistent improvement. And once again, where we worked most aggressively with biology was the highest improvement. And if you go back to the water infiltration, it's the same thing. You work with biology more, you get more out of it. And these are the things, it's how do you put dollar signs to this? But I think any farmer would understand that if I can improve compaction, my aerated zone in the soil, it means a whole bunch of better things are happening. And water infiltration and water holding capacity go hand in hand in this. Before I get into the sort of some of the chemical changes and cation exchange capacity, are there any questions here before I go to the next slide?
Hey, Ken, just was gonna ask, so most of these are with the digester as well. So kind of the best results come at like using the full program, I guess.
So the best results are a seed dressing with plot 2 is seed dressing and in furrow year over year. Plot 3 is seed dressing and residue digester every year. And that's the only, and then a fertilizer reduction.
Right.
Plot 2 is, so one of the reasons I think you see a bigger response on plot 2 is we're using Omex fertilizer on plot 2. So biology actually, it leaves more room for biology to work better. Plot 3 is MAP, so your salts are working against the biology a bit, and that's probably why in both compaction and water infiltration, you don't see the biological effect as significant. And that's only a hypothesis, but you make a hypothesis, and if your data correlates with what you can make some conclusions. So yeah, that's the that answers your question, I think, Dave?
Yeah. No, I just wanted to make that a little bit more clear.
Yeah.
Yeah.
So in addition, so those are the physical changes, and actually, I'm gonna. Unfortunately, the video that I had, it's too big to share with you guys, but I'm gonna show you a picture of how
You can.
you can test your.
There was a Landon question.
Oh, yeah, go ahead there, Landon.
It's just in the comments.
Okay, what's the question?
Wouldn't more water just flush the soluble salts?
Braden.
Yeah, without proper soil structure, more water is going to flush a lot of things away. What we're looking at is increasing our active and reactive carbon fractions, so that a lot of that comes from not just from microbial necromass or plant decomposing plant matter. It comes from specialized root exudates that biology, a crop that's grown with biology in mind, can produce. And those root exudates, a lot of that carbon goes into the humic fraction. A lot of that isn't utilized by the biology is stored as an active form of organic matter, and that right there is gonna increase your anion holding capacity, and not just your cation holding capacity, but your anion holding capacity as well. So that's a good question, because obviously there's soils that are a little have less clay. This Langham one as well, but there are even sandier soils out there that biology is very important. It's very important to have a living root in those soils at all times to increase that active and reactive organic matter fraction.
No, and here's a picture that actually addresses exactly what you're talking about. We have the Nuearth guys have a video that really explains this trial. So on the left is actually soil from plot 2, and on the right is soil from the conventional plot. So this is called a slate test or macro aggregate stability test. And where you've got biology working, you get a heavy rainfall and it doesn't burst apart stuff. Where you don't have biology, that soil falls apart, and all this gray stuff that you see in there, that is actually things leaching out of the soil and running off into the ditch. Where you have biology, and we've got a really good video that illustrates this. In the end, at that video, this ball is completely disintegrated in the water, and this ball is still 90% together. And you could all probably drink the water on the left. It's clear. And the water on the right is full of a little scum and cloudy. So when you talk about a whole bunch of rain coming in, when you have biology, that cation exchange capacity and all those things that Braden just talked about, this is an illustration. Heavy rain, that soil holds on to all the nutrients and the goodies that you put on. Bad soil, it runs into the ditch. And that's what that cloudy stuff is. And this is a test that you can do to yourself. It's a very simple test. It takes about 5 minutes and in a screen and a beaker. And it helps you know whether, if I'm working with my soil, am I actually improving it? You can benchmark it, or you compare where you're using it or not using it. Okay, I'll go back to cation exchange capacity, and then that'll almost wrap up things here. So cation exchange capacity is a measurement of how well your soil holds on to its nutrients. And it's quite a technical answer in terms of how that actually happens, but it's really hard for a farm to improve your cation exchange capacity. And maybe Braden, after I finish talking, you can explain some of this on how you improve it. But so once again, in year one, all our plots had the same cation exchange capacity. Over 3 years, though, these are the different improvements and the percentage of improvements. What's interesting on the really salty, like brutal, year one, the crop came up, and in where it was so salty, the crop died and nothing, it was just a shriveled plant and bare ground. 3 years later, we actually got a harvest out of that same site. And part of that is your percentage change. So this is showing that there's something chemical is being changed in there. And the only thing we're doing is biology. Biology is doing something in that soil that's improving the chemistry in the soil. There's about 5 other correlated data that supports this that I won't get into in our research. But the reason I show this is when we're measuring our soil health, we have both the physical proofs, we have yield and net return, but the physical attributes that we were expecting to change, the changes in the chemical attributes reinforce and show us, yes, a program that incorporates our biology, our biostimulants, low salt fertilizers, humic acids, and a good physical plan. Biology is one piece of a 3 or 4 part plan in this, or even more bigger than that. But what it is to show you, so in these cases, a seed dressing and a residue digester, that comes out to, and after you factor in fuel and driving time, I'm going to say $25 an acre, $7 an acre for seed dressing, $15 an acre for the residue digester, and then about another $5 to $8 an acre for your fuel and time. But these are the benefits that come out of that. And the things that, we're continuing on with this site. Our plan is to do this 5 years research, and we may carry it on more than that. But we've pursued this because we actually work with farmers, dozens of them across that use our product. And they've been on a reduced fertility plan for 10 years, and they're maintaining yields, and they make a lot more money than they did in the past. So we've been learning from them. We've been doing our research to go, we know this can work, but every farm has different equipment, different things. So if you try this, what is the level of risk? And that's been the point of our doing our research, is so that we can explain to somebody, listen, if you spend $7, you're going to make money on that $7. If you spend $20 here over 3 years, this is what was cumulatively achieved on a really crappy piece of land. It's next door to a big ag show. Not if it was getting 80 bushels an acre of wheat, it wouldn't be an ag show. We started out with a pretty marginal land, and we're showing some really good improvements. Any questions on cation exchange and stuff like that, or before I summarize?
This is Greg Mazechka. I got something to add to that. Are you guys hearing me?
Yep, you're good.
Yeah, I had liver flat land that has like this really hard gumbo. I've been doing this digester and all this stuff for like about 3 or 4 years. And last year was a very wet year, so I seeded into very wet soil. And basically, on the majority of the land, I got nothing. But in this one strip where I plow in a drainage ditch, there was a beautiful crop and a nice big line where that drainage ditch went. So I did this year. I pulled out a deep tillage cultivator I haven't used in maybe 25 years, and I cultivated it, like basically ripped it. And I went with a penetrometer. Basically, before I couldn't even stick it in the ground. It was so hard. About 2 weeks later, I took that penetrometer and I stuck it in the ground, not where the shank went, but where it was missing. And I was actually able to stick it in the ground 4 inches, which was impossible before. So with this biology, by using this, if that ground is so hard and it's not getting any oxygen, you're kind of beating yourself up, beating your head against the wall without ripping it. So I'm going to see this year what happens after wherever there was a foxtail plant growing, I cultivated it. And where there was no foxtail growing, I didn't cultivate it. So basically the field looks like I did a bunch of patches, right? But and the interesting part was in the fall here, it was solid green. All where I cultivated was just like I grew a cover crop. So obviously everything was just sitting there, not doing anything. And when I opened that soil up, all of a sudden it just took a breath and it started growing. So I mean, the biology by putting this stuff on the ground is great, but if the ground isn't prepared for it, then it's not going to do anything. So some farmers may find that doing this is going well, I'm not getting anything out of it, but your ground isn't ready. Am I explaining this right?
Oh yeah, and I think Braden could. We're not enemies of tillage. There are times that merit till. And yeah, Braden, you're on mute right now. Because I know you've talked exactly to these types of situations or similar situations anyway.
Well, anytime you can, like, if you go ahead and if you know the ground best. So if that ground is impenetrable and has a lot of compaction, it is in a lot of areas it's going to be an anaerobic environment, especially in high clay soils. There's going to be a lot of anaerobic activity there, and the lack of oxygen for that long and in that large of an area is not a healthy scenario. So to add a little oxygen to the soil in timely fashions is not a bad idea. It's nice to, like you said, you've been on the program. That's good. You can repopulate that soil with an inoculant of biology, a cash crop, cover crop, you name it. Get some living roots in there to continue, because those living roots, if you can get a nice tap root in there, and they do a lot of extra tillage for you going into the fall, especially. So I've heard a lot of stories like that. We've had situations like that too, where we've had to heal some compaction zones.
Well, no, and if your compaction zone is like 1.5 inches down, your biology will only go as far as those roots go. Like it's your roots that take that biology through. And
well, it is. Then you're far, like
when you're recycling your residue, it's not everything staying in that uncompacted zone. Now, tillage radish and stuff can burst through deep, harder than 250 psi. But yeah, no,
Oh, there's a
When you
few.
have serious compaction, there are things that you've got to do, and that your story's a good illustration of that.
Yeah, and I also sprayed the digester on it after the cultivation. So
Yeah.
it
Yep.
was like that, whatever, with that cultivation, that soil was loosened up, that digester was going crazy on that soil, and that's why it was just like green, right? So obviously I got a good reaction to the digester.
Yeah, and I think what happens too, a lot of cases with that compaction, like once you break that open, the ground naturally wants to go back to that hard pan again. And you want to use the Eco T, and adding calcium and adding some humics along with that will help just alleviate that natural reaction for the soil to compact again. So you want to be careful, like that you keep the program up. It's like you're cutting a wound in your skin, and you don't want that wound to heal, so you have to do things to leave it breathe and have it arid.
Well, so really, the summary of our conclusions and uh, these snapshots that I have. So there's multiple sites that feed into this body of work. Like we would not be showing this if this isn't just one shot and one trick. That there's a large body of data behind that. So, things though that I just go, biology is only one element of a farm plan, but every farm should have a biological plan. EcoT is good because it's full function, it's biology, and it's a biostimulant. Biostimulants can call themselves a biological, but you're not buying biology. You're just stimulating something you hope in the soil. And what we're trying to illustrate as well here, or educate people on, is if you have a plan, soil is the only input a farm owns, and if you intentionally go, I want to improve my soil, you can. We don't have all the answers, but the reason we've done this research is to show that if you make an intentional plan to improve your soil, it can be done. And water holding capacity, compaction, all these different things, those are actually what make your farm more resilient. So then when there's the environmental stresses, your crop and your farm can deal with it better. Or when, Trump throws a tariff on and all of a sudden fertilizer prices go up 40% and you can't afford every piece of nitrogen for your farm, you can gain efficiencies. In a single year and over a multi-year program, you can actually make yourself more efficient. So anyway, that has been, that's the presentation. I see I haven't put the kids to sleep or you asleep, so that's a good thing. And yeah, if you have any summary questions, welcome to hear them.
I have something. I kind of joined late because my Zoom wouldn't turn on. But I'm planning to do a strip test this coming year with nitrogen, where basically I'm doing a strip where there's 0 nitrogen applied, and just bumping it up 20, 30, 40, and 50, and basically wanting to see what difference I'm going to get out of those strips. Just kind of trying to find my sweet spot for nitrogen, because the last few years I've been just using about 30 to 40 pounds of Absol N down, and I'm getting the same yields as everybody else around the neighborhood that's pounding the nitrogen in. So I'm kind of interested to see how this was, because I had 2 years ago, it was an accidental experiment, because my air tank had a leak and I didn't put any urea fertilizer down at all, and still got 40 bushels an acre of wheat due to 70, 75 where I applied. And then also I did a strip where basically I opened up the nitrogen and just poured it on. And all there was difference was just straw. There wasn't any more grain. So I'm kind of interested to see how my little experiment will go this year.
Well, every crop requires X amount of nutrients. Like it's, if you want so many bushels, it does require a certain amount of nitrogen, certain amount of phosphorus. But when you talk about regen, there's different ways to get that. And your soil attributes, how much organic matter you have, a lot of us, there are people that have a lot of knowledge, but there's nobody that knows everything about some of these newer practices, because that's nature. Our own product 10 years ago, we couldn't do the detailed taxonomy that our taxonomy, one test would cost $10,000 to tell us one thing. Today, that $10,000 test is $1,000. So we've been able to test way more and understand way more about what our biology is doing and capable of doing. But when you're making a plan, realize that, hey, that plant needs X amount of nitrogen. Do a soil test. Like you still want to know, and it's fine experimenting with zero just to see what happens. But hey, if you want a crop, you still need nitrogen and you still need phosphorus. But it's just, how do you get it? And microbes, that is actually what they do in nature.
2 years ago when this happened, I had a Cargill guy come out there and I said, you want to see a crop that's growing with no N, with no urea fertilizer? And he goes, yeah, sure. So he walks out in the field and he's standing in it. And he says, where is it? I said, you're standing right in it. And he looks and he goes, but it looks normal. I said, yeah. I said, what is it living on? I said, I was waiting for a wreck and it never happened. So, and it wasn't, the bushel difference did not show until the actual combine went across it. So I was shocked. I was shocked that my soil can actually grow a crop without any N. But I don't want to go there. But I mean, I still know that I need some N. But I want to find that sweet spot where my fields can, where I know I can grow a crop with that amount of N.
And that crop was on the Eco-T program.
Yes, it was. It was that's right. I remember 2 years on the Eco-T program. Yeah. Plus, it was also the seed treatment was done, and also too. But there is one thing: I did 2 foliar sprays because I was nervous I wasn't going to get nothing.
Yeah.
So it wasn't. Yeah. It wasn't like I got nothing. Like there was nothing there, but I got nervous and I sprayed.
Yeah.
I did 2 passes on that 15 acres that I thought was going to be like nothing, right?
Well, in foliar applied N, they say is a 6 to 10 times efficiency. So a lot of it has to do with timing, crop, this and that. But 1 pound of N is foliar is like 6 to 10 pounds N in your soil. Now it costs more because for that fact, but anything else?
Well, if we don't have any more questions, I just again like to thank you, Ken and Braden, for being on here, and all those who attended. No hurry to get off. If someone wants to stay on and BS about this stuff, go ahead. That's not a big deal, but I want to get the thank yous in ahead of time for everyone showing up, and Braden and Ken for doing this for us, and for Randy for organizing our Zoom part.
Yeah, thank you guys.
No problem. Look forward to doing a few more, and we'll get even better at it. So.
Yeah, exactly. And if you did enjoy it, for those of you farmers, please tell your friends so we might be able to get a few more on. It was nice to have 6 or 7 on. That was great, but the more the merrier, right?
Well, this is my first webinar experience. So it went a little smoother than I anticipated. Hopefully I didn't.
Yeah.
It wasn't just a verbal barrage. It was useful.
You did good. We all lost our virginity together.
Okay. Well, I'm going to go. Thank you for your time and
Thanks, Ken.
good luck.
Thanks,
Yep.
Thank you,
Ken.
gentlemen.
Thank you guys for being on, and it was good chatting.
Perfect. Stay warm out there.